quick introduction. We will go through all the agenda items to see what you can learn today. After that, we will focus a bit more on smart contracts to understand what flash loans are, why flash loans are collateral-free. We'll also look at some examples, and I will present you some basic guidelines on how to do some basic programming in Solidity for those who are interested in this, so that you know either where to start or how to continue if you already have experience with software development. Note that participation in this lecture is when you participate, you agree with the terms and conditions and the privacy policy we share on our website. Okay, so as you already know, Equalizer is the first dedicated platform that helps to equalize all the decentralized markets. It comes with several services already. Several will come in the following months. The Equalizer platform offers flash loans and vaults where you can deposit funds in order to allow the other participants of the market to borrow flash loans. An Equalizer bridge to transfer Equalizer tokens between Ethereum and Binance Smart Chain. This wonderful academy, of course, where we share our knowledge and educate as much as possible, where we show you how to do things, when you can learn new things, and how to get ideas. All the content of the academy is available in two places, namely in the Equalizer Academy GitHub repository and on the Equalizer website. In the section, you will see all the articles, the agenda items, and additional content when you can learn about flash loans, organizational details, and other relevant topics. As this academy grows, we will of course provide more and more content. All this content is shaped and created for you so that you can learn and grow. Of course, we welcome you to our Discord channel. Participation is very welcome, where you can exchange ideas, exchange knowledge, ask questions to us, to other experts involved in our project, where they can help you and move things forward in case you get blocked. And also, if you want to introduce yourself, maybe find new business partners, create new contacts, all this is extremely important, and Discord channel is the right place to visit. Why to join this academy? Yeah, we are here to teach you, where you can learn from the best in the field. We're providing the best possible content that is tailor-made for you. We will also create hands-on workshops where we explain how you do things and how you get things going, not just theoretical lectures, but an actual hands-on examples. And here, of course, you will learn everything about decentralized finance, everything about flash loans, about different arbitrage strategies, about different trading strategies you can perform with flash loans, how to design trading bots, and how to build new things. Now, what I want to really point out is that what we learn in general is like 10% of what we read, 50% of what we see and hear, 70% of what we discuss. And for this first part, of course, we have these lectures where we introduce new topics, present them, so you can learn all the basic stuff you really need to get going. However, the 95% of what you will learn is what you teach to others. This is why we really invite you to get on our channel, to get engaged, either ask questions or try to answer them. With this, you will achieve two things. You will, first of all, get answers if you're providing questions, or if you're answering the questions, you will ensure that what you learned and what you answer, that you really understand. And if not, you can always find additional resources or ask others in the group to help you and to move forward. So what will you learn today? So first, why same smart contracts can be deployed on different blockchains. So in order to understand that, we'll try to make a comparison with blockchain and a regular computer or smartphone. Then I will present you some basic topics about software development and programming. So where to begin? For those who know where to begin, you're always welcome to help those who want to start. And the ones who are professional in this, of course, you are welcome to help those who already began and know how to do some basic operations. And then we'll take a look at flash loans, why flash loans are collateral-free, and of course, some flash loan examples and what are the first steps towards borrowing flash loans, and basically tools that you need in order to borrow those. Okay, smart contracts. Smart contract is a software, like your operating system is a software. Anything you use, your browser is a software. Right? So smart contract is not different. Smart contract is a software that does whatever you tell smart contract to do, right? So in order for a smart contract to borrow a flash loan, you need to first borrow a flash loan, then perform different operations, and then return the borrowed funds to the wallet. Smart contract lives somewhere, so is executed somewhere, right? Same as your software that you're using on your computer or on your mobile is executed on a chip of your device. Smart contracts are basically executed on some kind of a virtual chip. And this is called an EVM. Virtual machine, as the name suggests, is something digital, right? It's not like physical, like a silicon chip inside your device, but it's something that mimics the behavior of a chip, let's say, in an existing environment. Ethereum virtual machine has important property that is part of a blockchain, so is integrated in the blockchain client itself. And the smart contract is basically executed inside this Ethereum virtual machine. In order to trigger a smart contract, you need to send a transaction, right? So steps to call a smart contract and perform operations are the following. First, you need to write a smart contract. You will need to compile it into a machine language so that the EVM will understand the smart contract. Then you will need to deploy it. This deployment on the smart contract will store it to the blockchain, and then you will call a smart contract function by sending a transaction. When you send a transaction, what effectively happens is that smart contract function will be executed by the EVM. And during that process, your function that you will define in a smart contract will be able to read and write to the blockchain. And the only additional input information smart contract can get is from the transaction. So the only thing you need to somehow remember here is smart contract is a software. It will be executed on the Ethereum virtual machine, and it can get input either from the blockchain or from the transaction that triggers the smart contract method. Now, let's try to take a look at an example of a smart contract. So here on the Academy page, we presented an example of how to borrow a flash loan, very simple example that we will go into details later. But let's take a look what happens here. So we have a contract, and this contract is basically consists of something you can read, right? So you see it's written in Solidity. It has functions, and the function has some input parameters and performs some operations. We'll go a bit later in details what happens here, but this is basically what you write. When you compile this, you will get this here, right? So these are bytes. And the EVM part here understands this here, this part here, right? So you really don't need to understand how this conversion happens and what's behind it. I just want to explain what happens when you compile the smart contract. So when you compile a smart contract, basically means that you transform it from a human readable form to something that is understandable by the Ethereum virtual machine that is running on the blockchain. Now, of course, you need to know there are some languages that don't require such conversion, but Solidity is not one of them. So this is why when we will go a bit deeper, when we will say that you need to write the smart contract and compile it, you need to do it in order for the EVM that runs on blockchain to understand your smart contract. Now, this is important for one other reason. Ethereum virtual machine is a virtual execution environment, where smart contracts are executed. And I made a parallel with the silicon chip inside your smartphone or computer, right? Or in any digital device, doesn't matter. And many blockchains, such as Binance Smart Chain, Polygon, and others, are using the same execution environment. This means that if you write a smart contract in Solidity and you compile it, you will be able to deploy exactly the same smart contract on multiple different blockchains. And this is extremely important if you want to build decentralized applications that can run on different blockchains, that you understand that if you write a smart contract once and compile it, you can deploy it on different blockchains. And this is a really nice property of reusability principle, but this is the part that really enables you to deploy the same smart contract on different ledgers. Now, when you will write a trading bot, for example, and you will deploy it on Ethereum, you will be able to use exactly the same code to deploy, for example, on Binance Smart Chain, Polygon, or other what we call EVM compatible blockchain. So there are multiple clients. Basically, you can take any of these clients like Go Ethereum, Hyperledger, Besu, Quorum, just to set up your private local network. And that private local network, these nodes, will have an EVM as part of it. And you will be able also to deploy those smart contracts there to test things, to optimize things, or to understand better the operation. So those who are interested, I really invite that you try not only to use some online tools to deploy smart contracts, but try also to set up a local node. I mean, usually all these Go Ethereum clients and others come with a very nice example that with few clicks, you have a local network up and running, and you can start to play with it and explore how all these things work, right? So here's also a nice explanation, EVM on the Ethereum website. For those who are more interested in the details, Ethereum documentation also provides some details on how these things are built, how these things are executed, what are the details of the whole stack. If you check this from very high level, it really looks like a small computer, right? It has some memory, it has storage, it has some stack, okay, programming counter, I guess, available. Those are usually not part of a computer, but it has all the basic building blocks. And this is also why it's called Ethereum or a virtual machine. For those who are interested, I really invite to dig deeper and try to understand how these things work. But if you just want to write smart contracts and deploy, going any further than we presented now, it's really not required. Now, let's go to a bit more practical part, right? So developing smart contracts or designing software. So smart contracts, as I mentioned, is a software, right? In order to write and deploy smart contracts, you have two options. Either someone writes it for you or you design it yourself. It is maybe for those who are still deciding whether or not to start learning to program or go into software development. We need to understand today's software is everywhere, right? And it's in all digital devices. I mean, basically the software needs to be designed, developed, maintained, deployed, monitored. So there's a plethora of options for getting involved into different projects. And this is a really good motivation to start learn to develop things. And I guess that many of you who join this program also want to take some parts and bits of it and to learn at least the basic or the ones who already know how to develop, to improve their skills or to get some knowledge from us so we can advise you how you can get better. Of course, you can build your own software, you can design your own project, but you can also build software for others. Now, we need to understand that learning takes time. So there's no magic lecture, no magic book or something that you just take and you simply need to practice, practice, and practice. And over time, you improve your skills and become better and better. Remember what we said in the past. Before, we learn 95% of what we teach to others. So sharing your knowledge with others and interact with other participants in this academy is crucial, because this will bring your knowledge really on a different level. Okay, here's a short questionnaire. You can answer in the chat, or you can answer in the academy channel. I mean, who wants to learn how to design software or to develop software, and how much experience do you have with the software design or development? Feel free to provide some feedback and answers. Also, everyone else who will watch this lecture later, please join our channel and share your desires and interests, so that we know how to shape the following lectures of this academy. Either we keep it more theoretical, or try to provide more hands-on hands-on experience and examples, or we organize some other workshops with experts that will help you to design these things. Okay, I see a question in the chat. What of the 3 EVM do you recommend? Okay, let's jump back. So Ethereum virtual machine is only one, and all these different softwares run basically have a different implementation of the same technology. So no matter which one you use to test or interact with, you can use any of these. Just to clarify that question. Solidity is a programming language that is used to build EVM compatible smart contracts. Let's take a look at where to begin with. Every language has its specification and documentation. But to start with the documentation, it's usually very hard, because these are usually very long documents going all kinds of details that for someone who wants to start with software development might be a bit too much. So it's always better to start with examples instead of using all kind of installation and go through all the details. There's a very nice online tool that enables you start with software development, also with Solidity. Let's take a look of this very simple example. We will not go through all the details, but just to explain you the major part of a smart contract. So what we're looking at is a very basic smart contract. In fact, if you visit the Remix website, this is what you find as one of the default smart contracts you can take a look at, and you will see it consists of several parts. Before you begin programming, first you need to design the software you want to build. With design, I mean you need to know what you want from a specific smart contract to do, right? And the storage smart contract, as the name suggests, enables to store something and enables to retrieve or read something. This is like a very basic operation, right? Now, without going into all the details, we see that we have something that's called contract named storage. So storage is the name of the contract, and it has a placeholder, says this is called number. And this number has a type uint. This means unsigned integer, so only positive numbers, positive integers. This storage will be able to store one value, which is a number, and has two functions. It can store things and retrieve. When you will call the store function, it will set, so you will call store and you will provide some argument name. And what this method will do will simply update the value of the storage and store it on the blockchain. If you remember from our diagram before, this is what happens when you call the following method. Let's assume that you send a transaction that calls the store method. As an input, you will need to provide a number. When this transaction enters the blockchain, it will trigger the smart contract. In this case, it will call the storage smart contract. And inside that smart contract, it will call a function called store. Once this is done, the value of number will become the value you set in the transaction. If you set that number in your transaction is 3, when the smart contract is called, once this is executed, smart contract will write, in this case, to the blockchain, and number equals 3 will be written there. If you want to read from the smart contract, you don't need to send a transaction because read operations are, in this case, free, and it will simply return value of the number. So it will call the smart contract. Smart contract will read from the blockchain, and it will return value, in our case 3. Now, this Remix online tool it's very convenient because you don't need to install a compiler or anything else. So you have everything here. You simply click on compile, and you can also deploy on different blockchains, right? So you connect using MetaMask or your local ledger. You select an account, and voila, you will have your smart contract deployed, and you will be able to inspect the smart contract you deploy on on the blockchain scanner of the corresponding network. This is basically a very brief introduction in the let's say design and development, where to begin with, what to look at. Do you have any questions? We have 2 questions. How much funds are available for flash loans? To learn how much funds are available for the flash loans, you can always visit the Equalizer app and check the Equalizer vaults on different blockchains. These vaults here will show you how much funds are available, for example, EQZ, BUSD, REP BNB on different blockchains. The more funds are deposited, of course, more is available, but you can always check this in our Equalizer application. How you write code in Solidity for arbitrage? Can you share an example? Today, we will only look at an example of how to borrow. So we will do 2 things, basically. First, we will take a look of a transaction that perform a successful arbitrage. Second, we look at the very basic smart contracts that borrows and returns from funds from Equalizer vaults. How to perform an arbitrage requires several more steps, like finding the arbitrage in the first place and then executing different transactions on different operations in a smart contract. So basically, in high level, we will describe what is necessary, but only in the following lectures, we'll go into a bit more details, what is really required to identify an arbitrage, so to find an opportunity, and then what is the effort required in order to trigger a transaction that can then compete with other traders that also submit transactions to perform arbitrage. So basically how to come to that point. Whether or not your arbitrage is successful depends on many factors, and we will of course try to explain and understand what you need to consider in order to avoid the potential pitfalls. There's another question: why a flash loan might fail to deploy it? There are several ways why this might fail. In case you're experiencing any issues, feel free to share the outcomes on the Academy channel, and we will be happy to help and look into the details of what went wrong and help you out there. We also collected several useful links on where to begin with Solidity development. One is a collection of Microsoft lectures, Get Started with Blockchain Development. We will also, in the following weeks, come up with some learning packages where we will share some challenges with you, and you will be able then to solve them and to with in a guided manner to learn how to solve some small challenges in Solidity. For those who are more game-oriented, there's another interesting page called Crypto Zombies. Crypto Zombies enable you in a bit more gamified way to get started This is more for beginners who don't have experience in programming, so it's a bit more fun, less reading, more actions. So these are really things you can begin with. And of course, many other lectures available online. However, know that learn to develop and test things requires patience, time, and of course to interact and try to teach others, because this is really how you will see if you understand what you learn, and also share your knowledge with others. So to recap, for those who want to begin read and learn, start with small examples. If there's something too complicated, simply skip it and try to find something that you can really understand from beginning till the end. And the more examples you solve, the better. And the better you understand the small pieces of code, the easier you will be able to grow and extend your knowledge. Really try to understand when you develop and design things, all parts of the code, because sooner or later you will come to a point when, if you skipped something and didn't understand in the past, you will need to study it at some later point in time. And of course, as you have more and more experience, you can go with to more complex examples. Now, for those who already know how to program, it's important to read and learn. I mean, the more you will understand specification of a language, the more you will be able to use all the capabilities of Solidity, the more you will know how to optimize the code. And as we will see in one of the following lectures, that optimization will become an important part when you try to compete with others. Exchange experience, ask questions, and answer questions are more important than, again, teach. Okay, are there any questions so far? Okay, yes, you are new and you want to know how to use the app. We will, of course, take a look at examples how to use Equalizer platform and how you can benefit from it. Yes, we will go through an example of how to borrow a flash loan in a second, basically. Solidity hands-on workshop. Another question for you. Feel free to respond in the Discord Academy channel or in the chat. If you express interest, we will organize a hands-on workshop where we will guide you through different steps on development, deployment, and interaction with the smart contract. Okay, and now let's go to flash loans. So Equalizer offers most optimized flash loans on the market. We managed to do that because the Equalizer team is really experienced and has the best knowledge in smart contract design and development in the field. And if you check, we performed different comparisons with existing flash loans providers like Aave, the Index, the DY, and we see that the Equalizer flash loans are almost twice less expensive in terms of gas than other flash loans providers. There's an interesting application called Tenderly that enables you to, for those who are a bit more experienced, to analyze how optimized your smart contract is. We will see which methods are called, how costly different methods are, and this will also will help you to understand why your smart contract uses a lot of gas, for example, and where you can optimize. Now let's take a look at a basic flash loan transaction on Etherscan. Here is basically an arbitrage, and we will see that to execute an arbitrage, there are several steps that are required to execute. So this is a transaction. You can inspect all the transactions on Etherscan, and it's really interesting to inspect these transactions to try to learn what happened or what was the business logic of the smart contract that performed these actions. Because, as you know, in order to use the flash loan, you will need to design and then develop some kind of business logic in your smart contract. In order to do so, you need to understand what others in the field do. Because when you compete with someone, you need to understand what is their logic. So it's for those who want to build some kind of trading apps, it's really important that you try to understand and inspect what happens in other, for example, flash loan transactions. Flash loan transactions are usually marked. This one is done by a Flashbot, so we will look at what this means at the later stage of the academy. It's not so important now, but now let's take a look how you can inspect this. One thing is to simply follow the path of tokens transfer, right? So we see that here wrapped ether was borrowed, then it was transferred, it was exchanged, there's another exchange here, exchange back, return the tokens, and return the wrapped ETH, pay the transaction fee, and voila, take the profit if successful. So even though this sounds very simple and straightforward, there were several steps required in order to perform these actions. First of all, a person had to find the right opportunity. It had to borrow the funds, perform several exchanges, make sure that the transaction is profitable, and return the funds and be better than everyone else in the field. Here, of course, you can see what are the input parameters, but this is not so not so important. But here you can learn more about this transaction in the state part. Now, we all know that blockchain consists of states. If we go back to the previous diagram, so EVM, so smart contracts reads and writes to a blockchain. And when a transaction is processed, this will lead to a new state. And here in this block explorer, you can simply observe how the state of this account changed when it went from one operation to the other, right? So we see that it began with this state, ended with this, and this was the state difference. And here you can also get details of what happened at different steps. We will not go into details, but I advise you to try to take a look, find more examples of flash loans, try to understand the logic that happened here. Because when you will try to build your own smart contract, you will first need to design the logic, which does not require any software development. It's a business logic you can put on paper, and then once you have the logic and it plays well, you can of course implement it. Now we see that flash loans are borrowed and returned using a smart contract, because smart contracts enable us to perform many actions. With a simple transaction, we can only transfer funds or invoke a smart contract, but the actual logic of what happens needs to be implemented in the smart contract itself. Now, smart contracts, as said, can perform other operations like arbitrage, rebalancing, and others. And we will go into more details of these business operations in the next lecture. So, to recap, the basic step your smart contract needs to perform is borrow flash loan, perform several trades, like to execute an arbitrage, and return the funds. And if you were fast enough and perform the right steps, of course, the arbitrage will be successful. If not, either it results in a loss or the transaction is reverted. So now to recap what are atomic operations and to understand why flash loans are collateral free. When you borrow a flash loans, you don't need to provide any collateral because everything happens in one transaction. As we see in this step, we start from one state, end with another state, and this is why we call that operations are atomic. And typical flash loans are usually borrowed for a longer period. However, flash loan is only borrowed within one transaction and is returned right away. So For liquidity providers, there's no risk to lose funds if the smart contracts are audited properly. And for borrowers, it does not require to provide any collateral. Operations are atomic, which we just checked now. And if transaction execution fails, the transaction is reverted, right? Or if you don't return the funds, your transaction will be reverted. So this is a safeguard for liquidity providers in order to not lose funds in any of these processes. Okay, now let's take a quick look at flash loans. In our Equalizer documentation, we provide a very simple overview of how to borrow a flash loan. This is a really high level, so how to do it in a high level without any programming. However, there's no business logic. So if you would deploy and execute the smart contract, you just borrow and return the funds in the same transaction. So the purpose of this document is basically to get you acquainted of the operations of a flash loan. So in order to do so, you simply follow the links provided on this page. And for here on the testnet, we deploy the smart contracts. And using Etherscan, you can actually not only read the smart contract, but you can also interact with it. So in order to do so, you will simply need to connect your MetaMask wallet and provide some input values. Now, for those who don't understand what to put here, we also provide here a set of values you can put in, provide this, call write. This will of course ask you to sign a transaction, and voila, you will interact with a smart contract that borrows and returns flash loans. Now let's go and take a look. What is the content of this smart contract? So as before, we have some parts of the code that are specific to the programming language, to Solidity. And there are some parts that, so you see, it's ERC 3156, which we will discuss after this example. And we have basically an interface and a flash borrower. And this flash borrower, what will do, it will simply set an allowance. So when this is called, a flash loan is already borrowed. Here you already have the funds, and this is the part when you will need to set your business logic. We will go into more details on the business logic in the following lecture. This is the part that is usually hidden by other traders because they don't want to reveal what they actually do. And of course, at the end of this transaction, you will need to return the funds if you return the funds. If any of these parts fail, your smart contract call will simply be reverted. So I invite everyone to take a look at this example. Try these values, play with them, try to understand the flash loan borrower smart contract, and come up with questions, suggestions, or share your experience in the Discord channel. And now let's take a look at this standard. The more you will start to develop and experiment, the more you will understand why standards are important. And Equalizer is following this flash loans standard, meaning that if your design follows this standard, you will be able to use whatever so all the trading bots you build, you will be able to use it with any provider who follows these standards. Following standards is crucial to optimize things, to reduce the effort to rebuild your applications. Testing and maintenance is also cheaper, and there's less room for error. So following standards is crucial, and follow them whenever it's possible. and whenever they are well defined and well established. Okay, so we came to an end of this lecture. We will share this presentation, all the links with you. So today we learned some basic of the smart contracts. We went into a bit more details on how smart contracts are structured, where you can learn more about smart contracts, and we took a look at a flash loan. For your homework, we kindly ask you to try and deploy your first smart contract. Check out the Solidity development tutorials we share with you, and exchange your knowledge with others. In the next lecture, we'll take a look at flash loan use cases. We'll check what is an arbitrage, what is a collateral swap, what is liquidation, self-liquidation, and go in more details in the business logic you need to understand and learn about, and what is required in order to use such examples. This is the end. Follow Equalizer, visit our homepage, join our Discord, Twitter, follow our read our articles on Medium, and of course provide feedback on Discord. If you have any questions, how to pay low fees on gas? Yeah, as mentioned, this will depend on level of optimization and on the network you use your smart contracts. So we will take a look at this into a later lecture on how to check and optimize things once we get more experience and understand all parts that are required to execute this. I would like to thank everyone and wish you a wonderful rest of the day, and see you in the next lecture.